Greetings to you, ladies and gentlemen. We meet in the course Management Accountancy, sometimes called Managerial Accounting. Specifically, this course is there to try and equip internal managers to be providers of information that will be required in the decision-making processes in organizations. Today, I'm going to look at one critical topic: cost, volume, profit analysis. What do we mean? In the life of a business, the managers need to know at which point they will start making money. Businesses are all about making money. Here I'm focusing on for-profit businesses, not for-profit businesses. Now, when we're looking at those businesses, they need to know how many units of production should be produced for the company to be able to make enough money to cover its fixed costs like rentals, pay every month irrespective of whether we've produced or not. Those are the fixed costs. Then we have got costs associated with the production of the goods themselves. We're talking of raw materials, labor hours calculated into dollars. All those are variable expenses that would depend with the volume of production or output. Now, I want us to pay our attention at this important point called break-even point. What is the break-even point? The break-even point is the point in the volume of the activities of the revenues and expenses are equal. Revenues and expenses being a negative, a cash outflow, money going out. When the money coming, that is the break-even point. Now, this break-even point can be X of production, the quantities that need to be produced in enough revenue, assuming these units are all sold out and matching. Now, I've got here a small table where I have got sales. You can see it on the slide as well. We've got sales of $250,000. Then they've had to do with the quantities produced, the products, the labor hours that went into it. So 50,000 is our sales, that's our revenue. We shall need to subtract the money that we used in order to produce the units that we sold in order to get the 250,000. Let's take an abstract figure and say it cost us 150,000 to produce the units that we sold and we got the 250,000. If we subtract the two, we will get this figure of $100,000. $100,000, we may say it's a gross account. It's the gross profit. Now, this money now is what will go towards the payment of the fixed expenses like rentals. Remember, even if we don't produce anything in terms of volumes, premises. Now, we need to sell in order to contribute towards the payment of the fixed expenses. They are fixed because they are always there whether we produce or not. Now, if our fixed expenses are also 100,000 and our profit is 100,000, then the contribution margin is the gross profit. It will now contribute towards the payment of the fixed expenses. If the 50-50 is such, 100,000 is the contribution margin to pay the fixed expenses, and this 100,000 is going all of it towards the payment of the fixed expenses, leaving us with a net income of nothing, of zero, then that becomes our break-even point. In this case, our break-even point in dollar terms will be 250,000, because this is the amount that if we get it, it will be able to pay the variable expenses and the fixed expenses, and we remain with nothing. Now, how do we arrive at these figures? Okay, if we look at our slide, we have got the sales revenue that we can see here, this sales revenue. This sales revenue, we got it by multiplying the selling price per unit we have produced goods that we're selling. And each good has got a selling price. The selling price, let's assume the selling price is what? $500. We don't know the sales volume as yet. That is the units that we shall sell. Okay. Now, we say it's X. The sales volume is X. So $500 times the X is representing the number of units sold. It will give the total revenue that we will receive. Number of units represented by X multiplied by the selling price. Now we've got variable expenses. Variable expenses, these are expenses that vary according to the quantities that you produce. If you produce more, you sell more. The expenses, they are to do with the raw materials. When we use more raw materials, it means we are likely to produce more as well. Now, let us say to produce a unit of this product, we will need $300 in terms of raw materials and labor input costs. The quantity sold here, we're assuming everything that we've produced, we're selling it here. So it's also X. So the total variable cost is the number of units sold multiplied by the production cost per unit. Assuming the 300, then we multiply by X. Now, we have got fixed expenses. Right. Let's assume we've got fixed expenses. So the break-even point is that point that satisfies this equation. Sales revenue minus variable expenses minus fixed expense. If I go back on the slide to where we were, right. Sales, okay, which are these? Sales revenue, 250 there. Here, it's now completely, we're just focusing on the equation. Minus variable expenses. We say when we net those two, we get the contribution margin. Minus fixed expenses should be equal to zero profit. Now we can say 500,000 multiplied by X, it gives us what? Let me write it there. It will give us 500X. 300 minus 300 times X, it gives us 300X, and we're subtracting this from 500. So it will be minus 300X equals to, when we net this, we'll get what? 200X. Now, this is where we got the X that you see here. If we come back here, okay, 200 in X minus 80,000, the fixed cost is equal to 0. Now, this we can simplify it. Minus 80,000 equals to 0, right? It's minus 80,000, okay, equals to 0. Okay, now, what does that mean? If we divide this one by what? By 200 this side, okay? We also divide here by what? By 200. Am I right? Sorry. That's not it. We say 200X minus 80,000 is equals to 0. So what we do, this is 80,000, we must take this to this other side. So we remain this side with 200X is equals to, this one goes the other side and the negative becomes positive, 80,000. Okay, we simplify that, okay, by dividing 100. Okay, this one cancels itself, goes into 800 400 times. So our X is equals to 400, right? We've said the X is the number of what? Of units sold or units produced. So we need, for us to be able to get to a point of 400 units, because if we substitute into this equation, we'll get exactly that same amount. If we say 500X, if we sell 400 units, it will be 400 times 500, it will give us a certain amount. Then we say 300 times 400, it will give us a certain amount, which is the total of variable expenses. Then we subtract the 80,000 here for the fixed cost. It will give us what? 0. So Here we assumed, you can see where I wrote in, I think it's purple color then, surfboards. We assumed we've got a company, perhaps it's in Walvish Bay, that manufactures surfboards. Okay, so the break-even point is we need to manufacture 400 surfboards and sell them in order for us to get enough money that will cover the material for producing the 400 and leaving us with enough money to pay for our fixed expenses, the rentals, you name them, and we will not get profit in that regard. That is our break-even point. Now, we call this the contribution margin. Consider the following information developed by the accountant. For each additional surfboard sold, right? Sorry, I put Oshvelo there. Take that one to be Walvish Bay. For each additional surfboard sold, 200 is generated as a contribution margin. Per unit, this is what we're looking at per unit. Let's go to the slide as well as the paper that I have here. Okay, remember our example, the first figures, these ones. We have looked at them already the first time. Now, we are now taking per unit costs. Per unit, we are selling each unit, selling price of 1 unit of the surfboard, it's $500. Production material, $300. Then for each unit of, that is for each surfboard, we have a contribution margin of $200. What do we mean by this contribution margin? It means that $200 is the one that is contributing towards the payment of our fixed costs at the end of the day. Now, we can put it as a percentage, okay? Taking the selling price is 100%, then 300 becomes 60%, and our contribution is 40%. Now, we still go on with our contribution margin. Let's look at how this is affecting ourselves. Okay, we now have got an important number called the contribution margin, per unit contribution margin, this one. Right, this number, we'll be using it, it will be helping us in our calculations. Okay, now the break-even margin. Once we know the unit contribution margin, and we have got a figure for our fixed costs. If we say fixed costs, I'll say FC, fixed costs, divided by the contribution margin per unit, right? I'll say per unit. It will give us the number of surfing boards that we need to sell in order for us to break even. So here we said our fixed cost, remember, it's 80,000. We put it there. And our per unit contribution margin is 200. By dividing these two, that is this formula, we'll get the 400 surfboards. These are the number in order to break even. Break-even points are so important because you need to manage your activities in the organization to say, guys, if we don't produce so much, then we are heading for disaster. At least we should get something to be able to cover our fixed costs. Okay. Now, let's look at what we've just done, okay, in terms of dollars. Suppose we have got $200, okay? Sales, if we sell 400 safes, okay, we'll get $200 there. This $200 is the amount, okay, let me begin by the middle one here, okay? If we sell we have said each one is $500, okay? Then we sell 400 of them. How much do we get? $1,000 as our revenue. Okay? Then we want to see the variable costs of these 400 that we have sold. Okay? What do? We know that the cost of each it's what? Per unit variable cost is 300. 300 multiplied by the 400 units that we've produced, these 400. We get 120,000 is our total amount for variable expenses, the raw materials, you name it. Now, if we say the revenue that we've obtained from selling our break-even point, at our break-even point, and the variable costs at our break-even point, we will get a contribution margin of 80%. That's 200,000 minus 120, right? And remember, we said our fixed expenses are 80,000. So if you say the 80,000, the contribution margin minus the 80,000 fixed expenses, will get 0. So this is the break-even point. This is a proof, because when we calculate now, it's giving us 0. And we know that a break-even point is a point where the organization produces and sells a number that will result in it getting a profit of $0. And this is what we mean by the contribution margin. Now, I want us now to go further and look at the contribution margin ratio. Right. Once we get this contribution margin ratio, we can use the ratio to get our contribution margin in terms of in dollar value or in units of production. Now, let's look at this formula that is given here. We now know our contribution margin, okay? We've said our contribution margin, if I can take you back again, our contribution margin is 40%. When you look at the slide, the last column there, it's our contribution margin, it's 40%, right? And we know our sales. Our sales in terms of percentage, it's 100%, or the total of revenue from our sales is 200,000. So we can now, once we have got those ratios, we can play around with them. And we know that contribution margin divided by sales is equal to contribution margin ratio. Okay, now, what do we mean? Let's have a look at the next slide. Okay, if we look at our contribution margin here, right, and we divide it by what? By sales. If you look in the first column, let me substitute this one by this. Our sales figure, 300 units, they were giving examples. If we have got 300 units there, right, we've got 400 units there, we've got 500 units there. What we want here to prove is to prove that this is really the position that we need. Okay, so suppose the organization produces below the break-even point. Let's say instead we now know that we need 400 units to be sold, to be produced, for us to say we have a break-evening. Now, right, if we produce 300 units, what is the impact? It means, remember, we said each unit, okay, in terms of sales, it's costing 500. So we shall say the $500 multiplied by what? By $300. And this will give us what? This in terms of sales, $150. Okay? If we sell 500 units, it will be 500, right? Units, that's $500 multiplied by 500 units sold, right? And we'll get how much? 250. If we sell, we've already done the middle one. Now, if we do so, it also means our variable expenses. Remember, our variable expenses, right? This was our variable expenses, we get them by multiplying $300. If we say $300, okay, multiplied by how many units? 300 of production here. Multiplied by 300, it will give us this. This will be our variable cost. And when we net these two, $150,000 minus $90,000 will get a contribution margin of $60,000. They don't change because we've produced less or sold less. They will remain at 80,000. If we say contribution margin less the fixed expenses, our business would have run into a loss of $20,000. So we cannot afford to settle for 300. But suppose we exceed, this we already know that if we produce 400, we'll get zero profit. Suppose we give ourselves a target, the figures indicated in the last column. We produce 500 and sell 500. It means our revenue is 250,000. And if you say 500, we multiply them, 500 units multiplied by 300 what? Dollars each. It will give us, this will give us 150. And these variable expenses, now we subtract them from the total revenue that we get after selling the 500 units. And we'll get this contribution margin of $100,000. When you look at these figures, we are better now because we have got a contribution margin that is more than the fixed costs. So it means we can pay the 80,000 and still remain with a profit of 20,000. So once we have calculated the contribution margin and we know the revenue, the per unit selling cost, we can manipulate and play around with these figures to calculate the profits, to do a cost volume profit analysis. This cost volume profit analysis, we can also present it graphically. Right. If we look at the graph that I have here, okay. What I've done here, we have got the y-axis. This is the y-axis, and this is the x-axis. Along the x-axis, we have got units of production. And we know our fixed costs. Our fixed costs are represented by this straight. If you check, here, it's $50,000. So somewhere there, that's where we have got our what? $80,000. Our fixed costs. $80,000. Somewhere there. Okay, represented by this line. Now, we have got this graph that goes up there. It represents when we add variable costs plus the fixed expenses. This is the graph that will give us the total expenses. As you will see, it's going up because variable expenses increase as we increase our units of production. Now, we have said here, if this graph, what we do is we can say, okay, go back there. We say when we have produced the first column, if we produce 300 units, we get a net income of minus 20. Okay? So we go and plot it here to see where our dollars are. It will be negative somewhere further down here. You shall see it better in the next slide. At 400 units, we don't make any profit because if you go at this, remember at 400 units, our revenue, look at the middle column on the slide, 400 units produced, it will give us a revenue of 200,000. So to the revenue that is coming in, the revenue, it's 400,000. And at that point, we know we don't have any profit. The profit is zero, the loss is zero. So that will be our break-even point. Okay, when we produce 500, okay, if we produce 500, what happens is, go back. If we produce 500, we are seeing from the last column there on the slide, At 500 units of production or sale, we'll find we make a profit of $20,000, which is above the break-even point. This is what is represented on this graph. At 500 units, we get a total of 250,000. Compare this with the figure that is shown on the slide, the last column. 250,000 represented by this dotted line at 500, which is now above the total. It means at this level, the revenue is above, slightly above the total expenses, right? So that's the same graph that I'm showing there. Once we've done that, it means we've surpassed the break-even point, which is at 200, because if we were to draw there, that's when it was going to meet. So the break-even point, it is the point where revenue meets the total expenses graph, this point. The moment at this point, where this, if we had drawn it nicely, I think it was going to be somewhere there, back to 400. So that is how we present it in a graphical format. When we look at the graph that I've just also showing you, at our break-even point here, 400 units, amount 200. Once we go beyond this, you will find that our total expenses graph will be overtaken by our total sales graph. Saying, if we sell 100, remember, we're simply saying, if we sell 100 units, okay, what is our total sales? We know each sale is 500. At 100 units, you simply say 500 times 100. And you get what? 500 what? What will it be? We have said each unit sale is 500. Then we multiply by what? By 500. It will give us 25,000, which is half of this somewhere there. 200, what do we get? If we sell 200, it will give us 50, right? So it goes on and on, the total sales graph. But once we reach the break-even, you would find that the situation becomes favorable because our total sales figure will now be exceeding our total expenses figure. So from this region, this or this, as we increase our units sold, our profit margin, it's increasing. You see the distance between the two graphs increases as we increase our sales. Ladies and gentlemen, I think for now we can take it up to that, and I hope this will help you understand one or two concepts about cost volume analysis. Until next time, ciao ciao.